The petroleum industry is in transition, and by necessity, a great many petroleum geoscientists are also in transition. The aim of this course is to help us understand how we can leverage our critical thinking skills to help us ease that transition. So the issue is that petroleum exploration and production companies are transitioning to renewable energy, and a great many service companies are diversifying into environmental geoscience, geothermal energy, carbon capture and storage, mineral exploration, and much more. And of course, a great many petroleum geoscientists have lost their jobs. But we shouldn't panic. All is not lost. We are still the best geoscientists in the room. We are critical thinkers. We are problem solvers and systems thinkers. We are researchers and learners. We are project managers and data QCers. We are technical writers, illustrators, and of course, communicators, which is a pretty impressive set of skills and pretty much what any geoscience company is looking for. So what are we missing? Well, the thing we're typically missing is domain-specific knowledge. If we're moving into a new area, there's typically a new skill or a new area of knowledge that we need to assimilate. And that's a bit of a problem because I think so many of us have maneuvered ourselves into silos and believe that we can only undertake a particular subject. I've heard people say that I can't work on Jurassic rocks, my expertise is in the Cretaceous. To which I would answer, well, no, really your expertise is in learning about rocks. And you've proved that you can do that by learning about the Cretaceous. So now you need to apply that skill to learning about the Jurassic, and you need to do it fast. We need to get out of our silos. We need to recognize and practice the skills that enable us to move quickly from one subject area to another. Here's another example I heard more recently, that I can't work on geothermal because all my expertise is in petroleum exploration. But I again would answer, no, it's really an expertise in geosystems. And you've proved that you have that expertise by learning about petroleum systems. Now you can apply that skill to learning about geothermal systems. And it's very interesting in this particular example that they do have so much in common. So we're now learning that prospect evaluation, play fairway analysis, and sequence stratigraphy are equally applicable to geothermal exploration. So what we need to do is take stock. We need to build an inventory of the skills that we have already. We need to identify those skills. We need to clearly define them, understand them, recognize them for what they are, and acknowledge that we have them already. Once we have that initial skills analysis, skills portfolio, we can then look for the gaps. Where are the gaps in the knowledge and the skills-based competencies? And of course, then having identified the gaps, we can set about practicing the skills and gaining the knowledge to fill those gaps. And once we've done that, we need to put that newfound knowledge and skill into presentations and publications and videos and so on, in order to demonstrate that we have acquired the skill, we have the knowledge and the expertise. But that's easier said than done. We all have degrees to some extent, and that demonstrates that clearly we're able to learn. But how many of us were actually taught how to learn? Do we recognize that as an important skill? Is it a skill that we attempt to practice, to enhance, to develop? Because it really is one of the most important skills. And that's something we want to focus on in this course. As Alvin Toffler said, the illiterate of the 21st century will not be those who cannot read and write, but those that cannot learn, unlearn, and relearn. We need to change the way we learn, improve the way we learn, and move quickly with the times. It really is quite amazing that in the next 18 months, mankind will assimilate the same amount of information and knowledge as in the whole history of mankind. It's literally doubling every 18 months. So that learning skill, that unlearning and relearning skill is really absolutely critical. And part of that process is to understand how we see the world through our senses, our sight, our hearing, our smell, our touch. These are our cognitive skills. And we need to first understand those. But more importantly, I think, is understand the concept of metacognition, how we think about thinking, how we know about knowing. It's cognition about cognition. It's all about being aware of our awareness and understanding that we have these higher order thinking skills and the importance of these skills. Now, back in our early education, we were focused very much on cognitive levels 1 and 2 in Bloom's taxonomy of learning. We were very much remembering and maybe understanding the concepts that were presented to us. But what we need to be doing is applying, analysing, evaluating those pieces of information, those skills, that knowledge, in order to be much more creative in our problem solving, putting all of that knowledge back into more creative solutions. And this is really what constitutes critical thinking. This is a definition, I think, from Wikipedia, which suggests that it's the process of actively and skillfully conceptualizing, applying, analyzing, synthesizing, and evaluating information to reach an answer or conclusion. I mean, that's pretty much the study framework that we've been describing, and that's pretty much all of the cognitive levels within Bloom's taxonomy of learning. And this is what we want to focus on. We want to understand all of these processes, these cognitive processes, and then put them into action and use them to accelerate our learning so that we can fill those knowledge and skills gaps. And we need to become systems thinkers. I mean, here's a fun example of a causal link diagram that I actually built in a business process modeling software. But it's a very useful process to go through to understand the causal links between each of the components of a system. In this case, illustrating how you can link plate tectonics to pore systems, which seems pretty amazing to start with, but you can follow all of those links through and see how every component of the system is linked and how one part of the system causes changes in another. This is systems thinking. This is what we need to understand that we are doing and to practice doing. We need to know how we know. We need to understand that we're going through a cycle of research and internalization and recall of the information that we've internalized or stored in our knowledge management systems, and then understand how we are applying that knowledge to our problems through our reasoning, our scientific reasoning and our logical argumentation skills, our hypothesis testing and so on, in order to come to conclusions which we can then throw back into our learning and research process. And it's a never-ending cycle, but we need to really understand all of the elements and the skills involved in that cycle so that we can accelerate that process and accelerate our learning. And what's the best way to learn? It certainly isn't lectures and reading, which we seem to spend a lot of our time doing. It's really teaching. In order to teach, you have to understand. And it's the best way really to test your understanding is to try and at least explain things to people. It doesn't mean you have to stand in front of a lecture theatre. You just have to explain concepts. And if you can't explain it to your colleagues, then make a video and explain it to yourself. And if the explanation makes sense, it is because you have understood. And this is essentially the Feynman test. Richard Feynman had a habit of asking everybody if they'd understood, and when they said yes, he would pick on somebody to stand up and say, okay, you've got 3 minutes to explain what I've just been talking about. And of course, a great many people couldn't, because whilst they had understood during the explanation, they hadn't actually internalized or learned what was being described. And that's the Feynman test, and that's something that we'll practice a lot during the course. So we need to gain all of these skills. We need to understand that we have the skills. We need to put them into some kind of framework. And the best framework I would suggest is the technical report. It's something we're already familiar with, that background, the aims and objectives, the database, analytical methods, results, discussion, conclusions. Each one of these steps in the study plan, in the project plan, in the report, Each require a different set of skills to gather the knowledge, to organize our ideas, to frame the question, to consider the evidence, to test the hypotheses, to make logical arguments, to present the conclusions, and so on and so forth. These are the skills that we want to ensure that we understand and that we know that we have, that we recognize and that we promote. And that's the purpose of this course. So what we will do during the course is we will start by looking at the anatomy of the technical report, looking at those different elements of the project plan, of the study plan, of the report itself, and consider all of the skills that are required for each stage of that study. Then we will look at how we plan those studies, the project scheduling and management skill, which is another critical skill that all geoscientists need. We will look at how we undertake research and learning and knowledge management, again, important skills for any scientists. And then we will consider analytical methods, the options available to us and how we document them and how we consider uncertainties and errors in the data and how we communicate those uncertainties and errors to our audience. Then, of course, we will focus in on the principles and terminology of scientific reasoning. We have some scientific reasoning skills already, but how deeply do we understand them and how rigorously are we applying our logic and our reasoning? Then, of course, we will focus in on looking at some digital illustration skills. Again, something that's very important that we should all be able to do. As drafting departments gradually disappear, it becomes a requirement for geoscientists to do their own illustrations. And then, of course, we'll look at the skills required to pull all of that together, to synthesize our findings and present it in our final conclusions and recommendations. Then the final step in the course will be to look at strategies as to how we can demonstrate these capabilities and communicate that we have these capabilities to our managers and our prospective employers. So we will be using Geolumina GeoSkills, which is a competence management platform that's we've built, and we will use this to evaluate our existing skills and knowledge-based competencies, and then we will compare those skill sets with other sectors such as mineral exploration, geothermal, hydrogeology, and so on. In the first instance, to identify just how many skills we have in common with those other sectors, but also in order to identify the gaps, to identify what we are missing. We will then select one or other of those skills or areas of knowledge and look at how we can focus and accelerate our learning and how we can develop the new skill, practice the new skill, develop the knowledge, and then test that we have that knowledge and then demonstrate that we have that knowledge. And one way to do that, of course, is to find a key paper on geothermal or mineral exploration and then get access to the data, which is available in a lot of national data repositories, download the data, process it, work it up, interpret it, undertake a mini study, test all of those skills, develop all the skills that we've talked about, and then prove that we have the knowledge and the skill by making a presentation, and ultimately create a portfolio of knowledge and skills to demonstrate that you are capable of undertaking these new challenges. So that's what I want to cover in the course. I hope that's whetted your appetite. I hope that's given you the confidence that we are prepared to accept these new challenges and to take on these new problems in these new areas of geoscience. I hope to see you on the course. Thank you for listening, and goodbye for now.